All right, students, this is lesson 713. In this lesson, we're going to learn how to solve systems of equations. Just to get a feel for what kind of equations we're going to be talking about, we'll do a little problem here about a farmer. Farmer Melvin has a farm with chickens and cows. He took a recent head count and found there were 81 animal heads. Find three possible combinations of chickens and cows he might have on his farm. As you're probably thinking, there's probably a lot of different answers here, and there are. But I'll just make a quick little table to show some of the possibilities. So chickens and cows. And one possibility, let's say he had 40 chickens. Then we're going to do 81 minus 40, and he would have 41 cows. If he had, say, 80 chickens, 81 minus 80 is 1 cow. Because the number of heads is just the same as the number of animals. So if he had 14 chickens, he'd have 67 cows. And the way you can check all those is just by adding them up and making sure they total 81 always. All right. So if x is the number of chickens and y is the number of cows, what equation represents the number of animal heads on his farm? Maya, would you like to share?
I would not.
Maya showed me on her paper, she's just a little bashful right now, that the number of chickens plus the number of cows, x plus y, will equal 81. So then there's Farmer Melvin's wife, Eleanor. She counted the animals' legs and found there were 252 legs. Find three possible combinations of chickens and cows that could have 252 legs. Now, what makes this problem a little different is that cows have 4 legs, chickens have 2 legs. So we have to take that into consideration. Let's make another little table here. Chickens, cows, and so let's say we had 124 chickens. And if you multiplied 124 times 2 legs, that would be 248 legs. And we have 252 total legs, so that leaves us with 4 legs for 1 cow. So 124 chickens and 1 cow would work. Another possibility, let's say we had 100 chickens. 100 chickens takes 200 legs. That would leave us 52 legs left for the cows. If we do 52 divided by 4, that would give us 13 cows. Another possibility would be 86 chickens and 20 cows. And just to show you the math on that, if I take 86 chickens times 2 legs plus 40, what did we say, 20 cows times 4 legs, add those together, I get 252. So those are how we're finding those solutions. But again, there's a lot of different possibilities here. Okay, so if x is the number of chickens and y is the number of cows, what equation represents the number of animal legs? And since we have to take our number of chickens and multiply by 2 because each chicken has 2 legs, we would get 2x plus each cow has 4 legs, so we multiply by 4y, and that would have to equal 252. So we actually have 2 different equations for the same problem. X plus y equals 81 and 2x plus 4y equals 252. When you take those 2 equations together, as we did right here, that's called a system of equations. And there's actually, when you have 2 variables and 2 equations, there's actually one solution that will be common to both. Possibly one. There may be an infinite number of solutions or no solutions also. But so given this information, can you figure out how many chickens and cows Melvin has? I'm going to leave that for class tomorrow. But basically what we're looking for is a value of x and a value of y that's true for both of those equations. And I think if we look at some graph situations, we'll understand more what it means to be a solution to the system of equations. So check these equations out here. Actually, you know what? I'm going to leave this one for class tomorrow. We'll do this one in class, and I want to get right to looking at a graph of this situation. You might notice in your packet that the scale on my graph is a little bit different than the scale on your graph. So on your graph, just double each of the numbers here, so that it looks like this graph. So make yours a scale of 2. All right, so consider the equations 3 and 4. Could you graph the solution? So I'm just going to write that here. Here's equation 3, and here's equation 4. We cannot find all the solutions because there's an infinite number of possibilities of x and y. We can graph those, the possibilities though, because they're linear. So we can graph a line that represents all of those solutions. So we're going to do that right now. And the way we're going to draw these graphs is, I think I'll put them into slope-intercept form, so I think that would be easier. This top equation right here, we can just subtract 2x from both sides. So we're going to subtract 2x over here. And when we do that, we get y is equal to negative 2x plus 7. And to graph that, we'll just put 7 on the y-axis, and then put a slope of negative 2, which means every time I go over 1, I'm going down 2. We can draw a line through that to represent all of the possible solutions. That's pretty close. All right, now we're going to do the other equation, 3x minus y equals 3. I think to solve this one for y, I am going to, remember this is negative 1y, so it's take away 3x from both sides. Now we have negative 1y is equal to negative 3x plus 3. Divide both sides by negative 1. And I get y is equal to 3x minus 3. So my y-intercept is negative 3. That's there. My slope is 3. So every time I go over 1, I'm going to be 3 higher. And we get that equation. Draw a line through that. Looks like that. Okay, and then it says, at what point or points do they meet? We can see they meet at one point right there. That point is 2, 3. At what values of x and y make both 2x plus y equals 7 and 3x minus y equals 3 true? That is, what is the solution of the system of equations? And that is when x is 2 and y equals 3, which is, again, this point that is on both those lines. In order to be a solution of this equation, it has to be on this line. In order to be a solution to this equation, it has to be on that line. So the solution that's common to both is the one point that's on both those lines, which is point 2, 3. So x is 2 and y is 3. That's what we're going to be doing in this lesson. We're going to be looking for a common solution to 2 equations, and that'll allow us to solve some little bit harder problems. Okay, let's do exercise 2 and 3 here. It says solve the system of linear equations using the following method. Rewrite each equation so y is alone on one side. Graph both equations on your calculator. If the lines meet, estimate the x and y coordinates. You know what, I think I'll do this in class because then I can go over more slowly how to use your calculator to make graphs. All right, so let's move on to this one. We have 2 equations here, x plus y equals 5, and 2x equals 12 minus 2y. All right, so continuing on here, sometimes the solution, let's check out these 2 equations, and it says graph both equations on the set of axes. I think the way I'm going to do that is I'm going to use the intercepts. So if I put in 0 for x in this first equation, that means y is equal to 5. If I put in 0 for y, that means x is equal to 5. So I have the points 5, 0, 0, 5, and 5, 0. And then I can just draw a line through those. And I get that. Okay, and then the other equation, I think what I'll do is Let's solve that for y. So subtract 12 from both sides. When I do that, I get 2x minus 12 is equal to negative 2y. Then I'm going to divide both sides by negative 2. So I'm dividing everything by negative 2. And I get negative 1x plus 6 is equal to y. So y is equal to negative 1x plus 6. So the slope, or the y-intercept is 6. And the slope is negative 1, which means I'm dropping 1 every time I go over 1. So that's those points. All right. And then, if I put a line through those, does it appear that the graphs intersect? We're going to say no, it doesn't look like they intersect. How could you verify your answer to part B? By looking at the equations. Those lines appear to be parallel, and so if the equations both have the same slope, then we know they're parallel. And the slope in this one equation is negative 1. If we solve this equation here for y, subtract x from both sides, we get y equals negative x plus 5, and that slope is also negative 1. So we can verify that they're parallel because the slopes are the same. So does this system of equations have a solution? No. And the reason we know is because the slopes are the same, the two lines are parallel. All right, let's look at one more problem. Let's check out number 7. Consider this system of equations, 2x minus y equals 4 and 5x minus 2y equals 10. The slope of the line for each equation is 2. How many solutions do you think the system will have? Well, we just saw that if the slopes are the same, the lines are parallel. So we probably think that this system will have no solutions because the slopes are the same. So without using a calculator, draw the graphs of these equations. So let's draw this first one here. Again, let's do the intercepts on that one since it's in standard form. If x is 0, then y would have to be 4 divided by negative 1, which is negative 4. So we're going to put a point at 0, negative 4. And then if y is 0, so if we put 0 in there for y, then 2 times 2 is equal to 4. So x is 2, so that's that point. So we can draw a line through there. And for the second equation, let's do the same thing. We'll find the intercepts. If x is 0, then we're going to do 10 divided by negative 2.5. All right, so we have y is equal to 10 divided by negative 2.5, which is 4. So the point 0, 4. Oop, that should be negative 4, right? 10 divided by negative 2.5 is negative 4. So 0, negative 4, that's this point again, right there. All right, and then we're going to do, if we find the x-intercept, we're going to do let y equal 0. If y is 0, then we're going to do 10 divided by 5, which is 2, which is this point again. Which means if I draw a line through those, I get that line there. What do we notice about these two graphs? The lines are on top of each other. The word for that is they coincide. So they're on top of each other. How many solutions do you think this system has? Well, since every solution on one of the line is also a solution to every one on the other line, this has an infinite number of solutions. And the reason this system of equations is different from the system in exercise 4 is because the equations are actually both the same. They do have the same slope, but they also have the same y-intercept. So the equations are the same exact, not just the same slope. All right, I'm going to end the video there. We're going to do the rest in class. Oh, wait a minute, I got to do this problem with you. Oh, you didn't stop yet. But this is the kind of problem we can solve now that we know how to solve systems of equations a little bit. the first sentence says Booker is twice as old as his younger brother Andre. I can represent that with an equation like this, where Booker is y and Andre is x. That means that Booker is twice the age of his brother Andre. Then it says 4 years ago, Booker was 4 times as old as Andre. Well, if y is how old Booker is now, then y minus 4 is how old he will be, or how old he was 4 years ago. And it says back then he was 4 times as old as Andre. Well, if x is how old Andre is now, then he was also 4 years younger 4 years ago, right? And back then he was 4 times as old. Now you might think that sounds a little weird, but if you think about ages, you'll notice that that this kind of a situation is possible. So I'm going to graph this first one, y equals 2x. That one's easy, the y-intercept is 0. Slope is 2, so I'm just going to go up 2. Every time I go over 1, draw a line. Okay, and then I'm going to simplify this second equation. Or else I could use point slope form. Maybe I'll use point slope form. It's actually written that way. So the point that we're talking about is 4, 4. That comes from here and here, if you remember point slope form. And the slope is 4. So let's put a point at 4, 4, which is right there. And a slope of 4, I have a scale of 2 here, so a slope of 4 means I'm going to actually be going up this far every time I go over 1. So up 4 over 1, that'll put me there and there. All right, and so if I draw that line through there, you'll notice they cross right there at the point 6, 12. Well, 6 is x and 12 is y, so what we're saying is that Andre is 6 and Booker is 12. And you'll notice that Booker is twice as old as Andre. Now think about that. If we subtract 6 from both of those, 6 minus 4 equals 2. Or if we subtract 4 from both of those, 12 minus 4 is 8. So this is 4 years ago how old they were. And you'll notice that 4 years ago, Booker is 4 times as old as Andre. So that all works out. But we can use a graph, we can use a system of equations to help us solve that. All right, that's the end of the video. I'll see you tomorrow.